So very good evening to everyone. This is week 0 or a dry run of the TA live sessions for the course Artificial Intelligence Search Methods for Problem Solving for NPTEL. I am Ritviz Kamal. I am a PhD student and a Prime Minister's Research Fellow in the Department of CSE at IIT Madras. And in these live sessions, we will be discussing the previous year's assignment question, or more precisely, the assignment questions from the previous iterations or previous runs of this course. So, to get started, we'll discuss the week 0 questions from the previous iteration of this course in this dry run. So, without further ado, let's get started. Yeah, so you see, uh, we are given an initial state and a final state. Now, which of the following are valid actions? So, if you remember, this is one of the examples that was discussed in the lectures by Professor. We have one robot arm, and the only valid possible operations are either to lift an object from on top of the table or from on top of another block, or to stack down a block from the robot's arm on the table or on top of another block. So, let's examine the options one by one. First is put down M. Now, we can't put down M because M is on the table in the initial state, actually on top of another block I and not in the robot's hand, right? So this is not a correct option. Let's look at pick up V. Now, V is on the table and it can be picked up by the robot, by the arm, right? So this is a valid operation or a valid action. Okay, let's look at C. Stack Y on G. Now, in order to stack Y on G, first Y should be in the arm of the robot. So this is also not a correct option. Let's look at D. Unstack R from O. Now this looks like a valid option. R can be lifted from on top of O and go into the robot's arm. So D is the correct option. Let's see. Yes. So B and D are the correct options. Let's move on to the next question. If pickup and unstack take 2 units of time and put down and stack take 1 unit of time, then what is the shortest time in which we can reach the final state from the initial state? Assume that we don't take any breaks in between. Now, see, we need to construct this final state. It has V in the bottom. So let's start from there, okay? V is on the bottom on this table as well, right? All we need to do is put I on top of V to get started. In order to do that, we must first remove M from on top of I. So what action can we do? We can unstack M from top of I, and then we must place M on the table. It's always better to place M on the table because we know that we won't be using it in the final state and should not create any hindrance in picking up any other block. So we first unstack M from I and we put it down on the table. Now I is free. We unstack I from B and then we stack I on top of V. Now we have Vi in an intermediate state. Next we have to choose B. Now remember, M is removed, I is already on top of V, so B doesn't have anything on top of it in this case. So we simply pick up B and place it on top of I using the stack B on I operation. We proceed in a similar way. We pick up G and stack G on B. Next we pick up Y. Next we unstack Y from W and then stack Y on top of G. Next, we need to access O. Before that, we unstack R from O, put down R on the table. Then we pick up O and stack it on Y. Next, we pick up R and stack it on top of O. Now we have reached the final state. Let's check the answer. So you see, these answers follow the 16 steps that we need to take from the initial state to reach the final state. And the unstack and the pickup operations are taking 2 units of time, while the put down and the stack operation are taking 1 unit of time, making a total of 24 units in the shortest possible way. Okay, so I hope that was clear. Moving on to the next question. Okay, let's call the plan which takes the least amount of time to achieve the goal, agreement, or arrangement, sorry, as the best plan. We just saw this arrangement in the previous question. Assuming we don't care where the block W lies once the desired arrangement is achieved, where do you think it would be lying if we follow the best plan? Now if you remember, in the previous question, we had removed Y from top of W and then we had not touched W, right? So it makes sense that W would remain on the table. Let's look at the answer. And it is correct, in fact. Block W will lie on the table, just like block M which will also lie on the table. Okay, let's move on to the next question. Can you recall this picture from the lectures and in what context was it used? A. To express the richness, the ambiguity, and the impreciseness of natural language. To entertain the idea that AI is better than humans at solving pathfinding problems. To illustrate that bad town planning leads to poor utilization of land. Or D. This natural language conversation scenario is being proposed as an alternate Turing test. Let's look at the image. Now, what's happening here is a person might be possibly asking the policeman for instructions to a certain place, and the policeman has a clear picture in mind, as can we see from the thoughts, the bubble thought that the policeman is having. He has a clear picture to reach the destination and he's conveying the same to the person. However, what the person is perceiving is quite jumbled up, not as clear as what the policeman is telling. Why is that? Because there is an ambiguity and an impreciseness, also a richness to the natural language that the policeman and the person are using to communicate the path to each other. Because of this ambiguity, what the policeman conveys to the person might not be the same that he intended it to be, right? So which of the following options is correct? A, right? Let's look at the answer. A is the correct answer. Okay, let's move on to the next question. So in the lectures, professor must have discussed about anaphora resolution, right? Let's look at some examples. Elizabeth told Lily that she scolded her because she was in a bad mood. Who does she and she refer to? Okay, Elizabeth told Lily that she scolded her. Now this could be referring to Elizabeth. Also, it could refer to Lily. Okay, let's look at the second she. She scolded her because she was in a bad mood. Who was in a bad mood? It could be either Elizabeth or Lily once again. So let's look at the options. Elizabeth and Lily respectively. Also, this might be one of the correct possibilities. This is not the only one. So we cannot say that this option is correct. Same goes for Elizabeth and Lily and Elizabeth. The correct option is that we cannot say because either of these she's could be referring to either Elizabeth or Lily, right? Okay. Now we move on to the next question. Of course, this is the right option. Elizabeth and told Harry that she scolded him because she was in a bad mood. Now we know from the names, assuming Harry is most probably a boy and Elizabeth is a girl. And who does she refer to? A girl, right? So Elizabeth has to be the one that both these she's are referring to. So the correct option would be Elizabeth and Elizabeth respectively. Let's look at the answer. And indeed that is the correct answer. Let's look at another example. The Millennium Falcon overtook the Imperial Cruiser because it was too fast. What was fast? Okay, if we look at this sentence, Millennium Falcon overtook the Imperial Cruiser. And for something to overtake something, it must be going faster than that thing, right? So the correct answer would be the Millennium Falcon was going fast. That is the correct answer. Let's take a different approach to the same sentence. The Millennium Falcon overtook the Imperial Cruiser because it was too slow. Now what was too slow? Of course the Imperial Cruiser, because obviously the Millennium Falcon overtook it. So the correct answer would be the Imperial Cruiser. Okay, let's look at the next question. So what are the last few questions involved? We discussed this just a few minutes ago. It can't be speech resolution. It can't be both. We saw that it is actually anaphora resolution. So A has to be the correct option. A is indeed the correct option. So these were the few questions from the week 0 assignments of the previous iteration. And since this was a dry run, we are going to conclude here. I would like to thank Professor Deepak Khimani, who is the course instructor for this course. I would like to thank Bhaskaran sir, who is the main TA for this course and also who is addressing and helping you with your doubts on the discussion forum on SWAM. I'd like to thank the NPTEL team and the PMRF team and the Department of CSE, IIT Madras. With that, very thank you and let's meet next week.